Using isometric layouts. This presentation argues the case for the use of system ISO layouts for all stages of project work, as they are a hybrid of P&IDs and models which take the benefits of both, so all information is contained in one place, with both process logic and physical layout shown in a format which can be read and understood by everyone from concept through to construction. They are fast to create and modify, contain all information required to create 2D GAs, fabrication drawings, or even 3D models, and used after the project is complete as a live record of the plant for use in audit, system maintenance and record keeping, as well as a basis to build upon for future projects. Once equipment locations are agreed in concept ISO layouts at feed stage, they are developed to have further detail as physical layouts result in accurate scope definition for all disciplines. For process, you can have correction of any errors in existing P&IDs, calculations for equipment as height, distances and friction losses are known. For instrument and electrical, cable lengths including heat tracing lengths. Mechanical, layouts show the physical space for access and maintenance tasks. If buying new equipment, they enable engineers to provide fabrication information for positioning of nozzles on vessels to suit specialist equipment required. This example shows set distance from vessel walls for required radar level equipment. And if you're adding equipment to an existing vessel, the layout facilitates advice from specialist suppliers to provide equipment to suit the nozzle locations, as shown for this breather valve and flame arrestor on top of a vessel. It's easy to upgrade the basic layouts to define the instruments to order. Here's an example of insertion depth of an inline instrument to suit the pipe spec branch tables. Civil and structural. Basic civil or structural requirements are sketched so the discipline engineer can create fabrication-ready designs with calculations. Health and safety. Early identification of issues to address and incorporate into the scope of work. Here's an example of doors added to the internal walls at the design stage as part of a rescue consideration within confined space. Operations can be engaged in the project earlier for layout proposals feedback. The information on the ISO layouts can be used to create 3D models for layout reviews if required. Once complete, all this information is passed on to contractors in the form of invitation to tender, so they can provide accurate quotes and raise any issues they see in advance of the work to further iron out any potential setbacks. Deconstruction work. All relevant information can be linked through this one ISO layout and can be used to assist all phases of the work. In this example, links have been added for quick reference to aid deconstruction work. Marked up P&IDs with break-in points, photos of existing equipment, RAMs for pre-task meetings, along with vessel GA and photo of area to assist with permit writing. Construction phase. This method is once again used during construction to link with relevant documents. P&IDs, Project F10, pre-construction information, safety observations, RAMs, relevant vessel information such as construction data, inspection report and 3D model. Information on each piece of equipment can also be linked into this layout to demonstrate all information is correct for the build, such as datasheet, confirmation of correct install location, loop drawings, certificates of hazardous area compliance, cable calcs, calibration cert. Because they are basic layouts, they are able to be quickly used to solve problems, recording the due process taken. Commissioning, including leak test procedure, identifying isolations, high and low points for filling and venting, as well as level sensor calibration checks. Snagging is made easier to track by giving physical locations and description of issues to resolve. As built. All information used during the previous phases can be linked from one common document, resulting in easy use for future reference, be that a HSE audit, system issues or maintenance. It can be output to a PDF so anyone can view, turn layers on or off to look at the systems in isolation, and links to any other relevant information can be made, including fabrication drawings for piping, operating and maintenance manuals, pipe supports and calcs, and handover documents. Future work. System modifications are able to be examined for suitability in upcoming projects can easily build on the existing layouts as they are in standard AutoCAD format. No specialist software is required, and the more they are implemented, the clearer the site layouts become. System analysis can be carried out from information on the ISO layouts, example of pressure relief studies, diagnosis and resolution of system issues, siphoning example, and inspection regimes, piping wall thickness scan locations. One question to address is how long does it take to draw a system up? Although they look complex, they are much faster to create and modify than a model. Here's an example of the creation of a vessel with a pump which took 20 minutes to produce. The video sped up to save time. Once an item is created, it's easy to copy, paste and rotate to suit the orientation. Before long, full system layout can be produced. A catalogue of standard ISO symbols has been created, which speeds this process up. Once the system ISO is created, this information can be made into 2D fabrication GAs or 3D model if required. But models take longer to create and modify, have limited use for the construction team, and do not convey all the information required in one place. Comparing the ISO layout with a model. First, you have to be able to use the software to look from different viewpoints for the perspective you want. Whereas a system ISO layout can be opened by anyone when saved as a PDF file and is manipulated to show all the information. Here's an example of the same system viewed in a model compared to the ISO layout. The model is real world, so items are obscured by equipment in front of it. Multiple documents are then required to be referred to for fabrication info, and you must click on each item to know what it is. Whereas the system isometric can include all the required information, including dimensions, in one ready-to-print document for the construction team, and hyperlinks enable fast access to fabrication drawings. All this information is easy to cross-reference with the P&IDs, such as line size, specification, direction of flow, fluid in the system, as well as equipment tags, isolations, and can be used to diagnose issues as a full physical layout shown. The only advantage a full 3D model created with advanced software has is the auto-generation of bill of materials, solved with Excel software.